Hello, all. Welcome to another episode of Neural Networking with Konverge AI. Today, we are thrilled to welcome Ashish Jagmohan to our podcast. He's a seasoned research scientist and technology leader with over 2 decades of experience in data science, artificial intelligence, and enterprise agentic AI systems. His career spans impactful roles at leading organizations where he has focused on developing cutting edge AI solutions designed to address complex business problems across industries. So, please join me in welcoming Ashish from Emergence AI as we dive into the world of Agentic AI and explore its game changing implications for enterprises. Agentic AI is something that Ashish, the audience wants to know a lot about, and it has been due to the advent of large language models. This Agentic AI has picked up in the last 3 months or so, really on high. There have been a lot of different frameworks that have come up. Enterprises want to see where they can apply agentic AI workflows, and there is a lot of chatter about it. So that's the first question we want to begin with. That we want to start broad. So how would you define agentic AI, and what are the most compelling use cases that executives should be paying attention to right now?
Yeah, it's a great question, Ketan. So, you asked two questions. What is an agent? How do we define an agentic AI? And what are some of the compelling use cases, right? So let's start with what is an agent? And that's a great question, and there's tons of definitions, right? But let's take a step back and let's go all the way back to the 70s, right? And to the notion of software agents, right? And so I think when we talked about software agents back in the 70s, I think the key idea was the notion that an agent is an actor, right? So it can choose and it can execute actions. And then if this agent uses AI techniques, perhaps some type of AI reasoning or planning, for example, in order to select its actions, then it becomes an AI agent. And then maybe beyond that, there is the notion of autonomy. Can the agent maintain a larger goal? Can it sense its environment? And then can it react to the state of its environment in order to progress towards its goal? And so this is, how even traditionally we used to think about agents. And then, as you said, right, over the last few years, with the advent of LLMs and general foundation models, and the progress that's been made, there's been, a lot of discussion and many definitions of what constitutes an AI agent today. And so maybe, to oversimplify a little bit, perhaps the way we should think about an AI agent is it's an entity to which one can delegate a task and expect to get it done. Maybe that's the simplest description of what an AI agent is. And how does the AI agent do that? When you delegate a task, how does it get it done? Well, it does so by sensing its environment and autonomously selecting and executing actions. And now in that context, if you think about modern day AI agents, they'll have components like LLMs. They'll have components like memory modules, right? They'll have the ability to retrieve from knowledge bases. They may have heterogeneous sensing modalities, right? They might be multimodal sensing. They might be able to understand language and video and what have you. And they'll have some AI-based reasoning and decision-making capabilities, right? These are all the constituent parts that go into making that AI agent. And then, depending on its sophistication, an agent might have other capabilities, right? It might, for example, be able to self-improve. It might be able to leverage and learn from experience and improve its own performance, et cetera, et cetera. But I think this general idea, right, that an agent is an AI-based entity to whom you delegate a task and it gets it done, I think maybe that's, a good way of thinking about it. Now let's talk about the other part of your question, right? So the second part of your question was, hey, what are some of the compelling use cases? So if you're an executive in the industry, what are some of the compelling use cases? And so, I think the interest in AI agents, as you said, right, especially in the last few months, there's been this upsurge. I don't think it's been sudden. It's gradually, as the capabilities have been developed, it's an organic upsurge almost. And so I think the interest in AI agents is driven by the seeming promise of generality that they hold, right? And so it feels like, oh, maybe, they'll be able to do many, many things. And so, for example, at Emergence, right, we've been exploring and we've already demonstrated use cases and workflows across several industries. Just off the top of my head, examples include supply chain management, right, collecting and analyzing data to support both reporting and decision making in supply chains. Quality assurance, right? That's been another, really interesting use case where we are essentially trying to automate testing, right? And you do this by simulating user interactions, by understanding the requirements automatedly, and what we found is that our agents can plan and execute test scenarios, and really they can reduce things that used to take weeks of manual effort. They can reduce it into hours, right, and help you identify bugs really quickly and generate detailed reports and what have you. And then many other industries: financial services, research and analytics, travel planning and booking, and many others. But then, so one way of thinking about this is the industries. Another way of thinking about this is what classes of work are agents most suited for. And I think if you think about classes of work, I think there are some classes, there are some types of work that just seem so well suited and that are kind of like low-hanging fruit, where agents are making, the quickest advances. And some of these include things like content creation, right? Generative AI excels at content creation. Some of these include things like customer service. And then software engineering. That's a huge area, right? Where agents are already having significant impact. As I said, I think the real promise here is the promise of generality. With their ability to use tools, with their ability to sense and plan, their ability to retrieve and reason over domain-specific knowledge, it just feels like agents could potentially impact just a staggering variety of enterprise work. And I think that's what makes this present moment so exciting, right? It feels like we're on the cusp of a new era where enterprise applications will just transform dramatically.
Great to know about that, Ashish. I think one of the key takeaways that you could get from your answer is that the areas of applications are broad. So it's right from code to the marketing function, or as we call it, code to customer service, to put perspective it. So that is one. And the second thing you talked about is this very simple definition which you put very well. So the keywords that you could pick up was that there is automation, there are tasks, there is delegation of tasks, but it's an intelligent delegation and solving of the tasks, as the artificial intelligence also slash large language models are coming into picture to perform the task. So there is a parallel many people can draw with the robotic process automation that people have been mentioning about. So many are calling Agentic AI as RPA 2.0. So it would be very interesting to see what are your thoughts on this, and how does Agentic AI go beyond traditional robotic process automation, especially in terms of integrations with enterprise systems, and how do these integrations work, and what role do application programming interfaces, APIs, play in creating that seamless flow?
Yeah, that's another great question, Ketan. That's a great question, right? Let's set branding aside for a second, right? Whether we call it RPA 2.0 or whether we call it agentic process automation or what have you, right? Let's leave that aside for a second. But fundamentally, I think the fundamental trade-off here is the trade-off between autonomy and flexibility on one side and reliability and determinism on the other, right? So what do I mean by that? Let's dig into that. As we, I think, well understand, traditional RPA involves hard coding automation, right? Yeah. And traditionally, some of the pain points with traditional RPA have been that it tends to suffer from brittleness, right? There's a lack of flexibility. So if anything in your system changes, your automation might, begin to fail, unless somebody comes in and then, manually updates it. So that's one problem, the brittleness. And the second problem is as you said, actually, right? The significant cost of integration. So every time I need to come in and build a new RPA workflow, if it needs to interface with heterogeneous systems in my enterprise, and that's a lot of work. Okay, so what is the promise that agentic systems hold? Um, so the real promise here is that, agentic systems can solve both these problems, the brittleness problem and the integration problem. First, by the fact that they can reason with some level of autonomy, um, they can reduce or even eliminate the need for hard coding, right? And that might solve the brittleness problem. And on the other side, integration is made easier because your agent just learns how to use tools and APIs from just their textual descriptions, right? And so, just to make this concrete with an example, right? You could think of a really simple agentic system where you have a large language model based planner. You give that planner a high level task. That planner takes that high level task, breaks it into a sequence of steps, and then each step is basically interacting with some API in your enterprise, right? That's a really simple agentic system. And to be able to do this, a good, if your planner is based on like a good large language model, a good tool using large language model, maybe the planner would really, all it really needs is the textual description of each of the APIs, right? Like maybe a Swagger spec. And just from the Swagger spec, it understands when to invoke an API and how to use it. And so obviously the ability, the fact that why can we do that today? We can do that today because LLMs have made all these advances in textual understanding, in tool usage, in code generation, and in multi-step reasoning, right? Those are the four factors that go into why we can do this agentic process automation today, right? And you can see how this would potentially make it much easier to integrate with your systems, right? All you do is provide the textual descriptions of your APIs and voila, right? The planner just takes off and it's running. Now, of course, so this is, the rosy picture, right? We've solved flexibility, brittleness, and we've solved integration. Now, of course, though, reality is more complicated. And that's where the trade-off comes in, right? So like one complication here straight away is you might have a large number of enterprise systems and you might have a large number of APIs. And if that's the case, you can't really take all of your API documentation and just stuff it into your prompt, right? So you need to do something smarter than that. A second complication is that you might have legacy applications that don't even expose APIs. What do you do with that, right? And so in reality, you do more sophisticated things, right? One way of solving this problem, and that's kind of the way that the Emergence platform does it, is that your planner could orchestrate across agents rather than APIs, right? And then each agent encapsulates one or more of your enterprise applications. So you could have a database agent, and you could have an agent for your ticketing system, or you could have an agent that handles all web interfaces, and then your planner interacts with these agents, right? But the real complication, right? This is, these are just the things that come up. But the real complication, I think, is that you're potentially introducing a lack of predictable behavior, right? You have a reasoning system, a system that's based on stochastic technology, because hey, LLMs, have displayed stochastic behavior, and so you might be, this might lead to unpredictability, which in turn leads to a lack of determinism. Hey, maybe every time that agent runs, it runs in a slightly different way. And it leads potentially to a lack of reliability if it's not done well, right? It might fail every now and then. And so that, I think, is a fundamental thing. So when we talk about RPA versus this brave new world, there is this trade-off. Yes, RPA is hard, but on the other hand, you need to design your agentic systems very carefully to make sure that they're reliable and they're deterministic. And, my take on this is that probably, so there are all these decisions that can be made. There are all these trade-offs that can be done here. For example, you could hard code certain aspects and you could leave other aspects to autonomous, decision making. Actually, a really simple example is even in your agentic system, right? You could, for example, have a fixed topology, right? To solve a certain workflow, I invoke this agent, then this agent, then this agent, then this agent, right? Instead of trying to autonomously select at runtime which agent to invoke, right? So there are all these games that you can play. I think where we will converge is that workflow and you will need to look at your workflow, you will need to look at your application, and then based on your workflow and application, you probably want to select the simplest, most reliable thing, right? The simplest combination of hard coding and autonomy that works for you is probably the right thing to do for your work, for your workflow, for your use case.
Right. I think some of the things that you talked about, the calendar example, I think that was something to be looked into, because you talked about a lot of different things, where you said that how you can use the textual language to do integration, but at the same time there is an architecture trade-off that you need to look at. For example, if it is a legacy system and there are no APIs available, or the non-deterministic nature of the large language models, and how every time you may run the prompt you may get a different answer, or the way it is getting executed due to its fundamental nature. So as a architect, from that architectural point of view, so are there any critical design patterns that are emerging in agentic AI systems that we need to know about in advance, so that we get the best of the integration as well as the best of the executions? And how can businesses
Yeah.
ensure that AI infrastructure is also at the same time scalable and adaptable to these complex workflows?
Yeah, that's a great question. That's a great question, right? So when I think about design patterns, maybe a good place to start are the four design patterns that Andrew Ng talked about early last year, right? So he had a series in his newsletter where he talked about four design patterns for agentic workflows, and then he spent a week describing each one of them. And the four design patterns that he talked about were reflection, that the system should be able to examine its own work and come up with ways to improve it. He talked about tool use, that the system, is given a bunch of tools, APIs, web, browser, etc., and it should be able to use those. He talked about planning. That was the third. The third was planning, right? The system should be able to do, multi-step planning. It should, multi-step reasoning, what have you. And then the fourth part of it was multi-agent collaboration, right? And like there are many workflows for which you will not have one agent, you'll have many agents, and then we need to coordinate. They need to collaborate and interact. So reflection, tool use, planning, and multi-agent collaboration, right? Those are the four design patterns that Andrew Ng talked about last year. So now going beyond that, as we've built the Emergence Orchestrator platform, there's a bunch of additional design patterns that we've discovered, right? Like as we've, gone about trying to build reliable, deterministic, multi-agent systems. And I think most fundamentally, the design pattern that has proven, very important for us is the notion of loose coupling in a multi-agent system, right? And so the idea is, many enterprises tend to have large numbers of heterogeneous systems, right? And many different applications.
So Ashish, why don't you let the audience know first the definition of multi-agent collaboration, and then dive into it, the nuances of
great.
that pattern.
That sounds great.
Yeah.
So one way to think about this is, so an agent, as we said, right, is a system to which, or is an entity to which you delegate a task and you expect to get it done, right? Now, think about, you might have an agent that's really good at a certain task. Like maybe you have an agent that's really good at using the web, right? You might have a different agent that's good at a different set of tasks. You might have an agent that's really good at interacting with databases, writing to databases, reading from databases, converting your questions into database queries, et cetera, et cetera. So the way that we see this evolving is that you will have many specialized agents that are really good at a certain set of things. And then many of your enterprise workflows will be built by combining these agents. Right. So for example, if your enterprise workflow needs you to interact with databases, needs you to interact with some APIs, and then needs you to interact with the web, you will build it using the database agent, the web agent, the API agent. Right. You'll combine those agents together. And so in multi-agent systems, we really are thinking about systems that go beyond a single agent, that involve multiple agents. And then the question is, given a high-level task that needs all of these agents to accomplish, how do you coordinate among these agents? Right? How do you break it up into a multi-step task? How do you invoke these agents? And multi-agent systems we think are just absolutely critical, right? That's how enterprise workflows will get agentified.
Right.
right, using multi-agent systems. Okay, and so now in that context, I think a fundamental pattern that we've discovered is the idea of loose coupling, right? Where the idea is that you have all these heterogeneous systems, and many of these systems will get agentified, but they'll get agentified, for example, by different vendors, right? Like,
Right.
maybe Microsoft agentifies, its software, and then, maybe your database provider agentifies its software, etc. And so when you're building a workflow for your enterprise, you will need to bridge across all of these, right?
Right.
Because there are all these agents developed by different vendors. And so what we've discovered is that building these systems through loose coupling makes them scalable and easier to build. So what does that mean? What does loose coupling mean? So by loose coupling, what we mean is the Emergence Orchestrated platform has an agent registry, right? And that agent registry has, you add agents to that registry. As you build more agents, or as more agents get added to your enterprise, you add them to that enterprise registry. And those agents could be developed by you, they could be developed by a third party, right? They could be built by providers like us, right? But all of them go to the agent registry. And then the orchestrator is an autonomous meta agent that just coordinates across all these agents that have been added to the registry. So the reason this is loosely coupled is that the coordinating across agents and building those agents can be done by different people.
Right.
You don't need to do this monolithically, where you're responsible for building every single agent and you're responsible for coordinating it, right? And so this idea of loose coupling has proven to be really important for us. It seems like this is how we will be able to scale and how we will really build these, right? Let me give you one other example. So the one more fundamental aspect, and we talked about it right in the previous question, is this idea behind how much should you hard code and how much should you autonomously route. And so there is this question of, even if you're building an agentic workflow, how hard-coded is it? And this has interesting applications, by the way, on how you build. So if you think about the different frameworks, like Ketan, you talked about, there are all these frameworks that have been developed over the last year, LangChain, AutoGen, what have you, right? Which framework you end up using for your agent or for your workflow depends in part upon how much are you hard coding and how much are you doing things autonomously. So for example, you can think about LangChain, and LangChain, for example, allows you to build these fixed topology workflows, use this agent, then use this agent, then use this agent. And on the other end, you have AutoGen, which does you can also build hard-coded, workflows,
Right.
but AutoGen allows you to dynamically route.
Right.
And it even has things like self-learning topologies, or maybe agents, you shouldn't even, maybe they should just learn how to compose themselves, right? So there's this entire continuum where what technology you end up building your stuff depends upon things like, depends upon these decisions. How much you hard code, how much you keep autonomous. And then there's, and then there's other design patterns, right? There's the question of what role does memory play in your system? How do you make your system domain specific, right? How do you bring in domain specific knowledge into the system, et cetera, et cetera. But I think these ideas of loose coupling and these ideas of, the trade-off between autonomy and what do you hard code, I think these are some really important design patterns.
Right. So I can see that every enterprise is going to have this multiverse of multi-agents
Yes.
at
Yes.
their disposal, with a central registry in place, and an orchestrator who is going to play that generator, operator, destroyer roles on these multiverse of multi-agents. So I can see that the enterprise, while implementing these multi-agent systems, which are going to be crucial, are going to face the implementation challenges. Some of the ones that you mentioned, like there is going to be integration with the enterprise workflows, or some vendor, which you gave example of Microsoft, for example, may have in their own softwares their own agents that they have deployed upon. So what sort of implementation challenges / best practices enterprise AI teams should be aware of?
Yeah, that's a great question, right? And again, so maybe let me draw from our own experience, right? Like, what are the challenges that we've come across, right, while building our systems, right? And so, okay, we've already talked about the notion, we realized very quickly that there are all these heterogeneous systems, and, how do we integrate? Like, the idea that we would build every agent is not scalable. So, and that's how we came up with loose coupling. There's also, we very quickly understood that, just for example, relying on APIs may not be good enough, because hey, you might have legacy systems that don't even have APIs. And so, one of the things that we did, for example, is, so I think what we realized is that there are certain foundational agents that you probably need, right? And so you need an agent that can connect to APIs. You need agents that can connect to databases. You need agents that can manipulate the web, that can manipulate web interfaces, right? So agents that understand how to, for example, use a browser, agents that understand how to interact with websites, etc., right? And so I think these are just some foundational agents that you need, right? So whatever workflow you're building, you probably need access to a good web agent, a good API agent, etc. Now let's go further, right? So let me further illustrate these challenges by describing. So let me take the our API connector agent, right? So and let me talk about some of the challenges that we face there. So the first is that even for systems that have APIs tend to be heterogeneous. And by that, for example, very specifically what I mean is that enterprises, for example, use a mix of SOAP and REST APIs, right? And each of them have their own quirks. So handling them correctly is critical, right? If you are building an API agent, well, it better be able to deal with REST APIs, it better be able to deal with SOAP APIs, etc. A second challenge that we ran into very quickly is the lack of documentation. We talked about how, look, to be able to operate an API, all you need is the Swagger spec. Well, guess what? Many enterprise APIs don't have comprehensive specs. So what do you do there? And there are interesting things that you can do there, right? You can explore the usage of those APIs in many ways, right? But that's a challenge, right? You may not have documentation. A third really big challenge has been benchmarking, right? And so if you look at the universe of benchmarks, there's actually very few benchmarks, if any, that are tailored to enterprise agentic APIs. And so actually, there are very few benchmarks that are tailored to enterprise APIs, right? Yeah. And so if you're building an agent that should be able to use APIs in an enterprise environment, how do you evaluate it, right? And so you really need to build benchmarks and evaluation frameworks that are suitable for whatever you're doing. And as we discussed in one of our papers that we put out last year, any evaluation of such a system has to evaluate different aspects. It has to evaluate, your API documentation probably sits in a database that you're retrieving against. So you need to be able to evaluate the retrieval performance. You need to be able to evaluate, the tool calling. You need to be able to evaluate the final response, et cetera, et cetera. But yeah, the whole benchmarking area is challenging for enterprise APIs, and it needs to be thought about very carefully.
Right. So one of the aspects when we are building any AI system, reliability is something which is very crucial, that you want to have the systems running. So how can enterprises effectively evaluate, which you also mentioned some points in the benchmarking aspect, evaluate agentic AI's performance? So particularly in terms of answer relevance or contextual understanding of the tasks and the overall reliability.
Yeah, that's a great question, and it flows really well from the last one, right? From the discussion we just had, right? How do we do benchmarking, right? How should we do that? And so let's take a step back again, and let's think about how we've traditionally done benchmarking. And by traditional benchmarking, I don't mean actually in AI and machine learning. I really mean in the IT industry, right? How have we handled benchmarking all these serious systems and technology advancements that we've made, the last 30 odd years? And so historically, if you think about this, right, if you look at it, major technology advancements have always been supported by rigorous efforts on benchmarks, right? So if you think about the IT industry, all the way from processing systems, all the way, like processors, all the way from the basic hardware, the processors and so on, all the way to, your transaction processing systems, all of them, we've developed enterprise grade benchmarks for these things over the years. And so, for example, for processors, we had things like the spec benchmark, the spec CPU benchmarks, right? We had Linpack and 3D Mark for supercomputers and for GPUs. For transaction processing systems, we had all the TPC benchmarks.
TPC benchmarks, yes.
And so one really good question is, hey, where are those how are we going to develop those benchmarks for agentic enterprise systems? We need to think about that, and we really need, equivalent efforts. And so, so with that historical context, right, let's talk now about AI agents in enterprise environments and how do we benchmark them. So, it's good to understand, I think, that these things pose some unique benchmarking challenges. And so, I talked about how there's really there's a shortage of enterprise benchmarks. If you look at, think about the standard AI benchmarks. We have, or LLM benchmarks, right? We have awesome benchmarks in math, in reasoning, in coding, but where are all the enterprise benchmarks, right? And so I think that partly is because of the unique challenges that the enterprise faces. The first and foremost is there is just such a large diversity of tasks and domains in the enterprise, right? So this question of is it even possible to design a small number of benchmarks that accurately, evaluate performance across this huge diversity of tasks? That's a really important question, right? That's a really challenging question. Then secondly, there is the question of when you're benchmarking a system in the enterprise, what are you evaluating? Are you evaluating its goodness at an end-to-end task? Or are you evaluating its goodness at using common tools that you use in the enterprise, right? So think about it, right? I can evaluate how good an agentic system is for the specific invoice processing problem that I have in my enterprise, right? That's one way of evaluating it. A different way of evaluating it is, hey, let me evaluate how good my system is at using databases. Let me see how good the system is at using a bunch of tools and applications that I use in my enterprise. Forget about the end case. Let's evaluate how good it is at the tools. Because if it's really good at the tools, hey, I can always compose those to build my enterprise workflows. But this question of should you be taking a task-specific approach or should you be taking a tool-centric approach? It's an important question. And by the way, I don't think there's a right or wrong answer here, right? It'll depend upon your use case and it'll depend upon what you're trying to do. And then thirdly, we talked about, the fact that there's such a wide diversity of tasks. We've talked about, look, there's a task-centric evaluation and there's a tool-centric evaluation. And you have to figure out which is the right one for you. But then thirdly, and this is really important too, I think there's this trade-off between reproducibility and complexity. And by that, what I mean is, let's take web agents, right? So if you think about web agents, there's been a variety of benchmarks proposed over the years, right? There was Mini-Web, there was Web Arena, there was Web Shop, there was Web Voyager, et cetera, et cetera, et cetera. And some of these were kind of synthetic benchmarks. There was a synthetic sandboxed environment, and you evaluated your web agent against that synthetic environment. And then there's certain ones like Web Voyager that are on the real world web, on the internet, right? And so you evaluate it on real world tasks. Which one is preferable? And the answer is there's a trade-off here. The synthetic benchmarks, it's possible they're much easier to evaluate. When your agent does something, because the ground truth is fixed and static, you can evaluate how well your agent is doing. On the other hand, they might be overly simplistic. So real-world benchmarks might reflect the real-world complexity, more realistically, but then they're harder to evaluate. And so again, this is fundamental question of when you are trying to evaluate your agentic system, should you have a synthetic benchmark or a real-world benchmark? So I think these are some of the key things that come into play. And so, for example, right at Emergence, when we recently announced what we call the eWeb benchmark, which is a benchmark that is specifically focused on the enterprise. And so we made some choices there. We decided that skill-centric evaluation was more useful for that benchmark than task-centric evaluation. And we decided that real-world relevance, trying it on real-world things, was more important, even though it made evaluation against ground truth harder. So I think those are some of the trade-offs and some of the decisions you have to make when you decide how to benchmark.
Right. So speaking of benchmarks, barring the technical benchmarks, one benchmark which is always there on the usability side is the adoption or user
Yes.
adoption, and that is one of the things that everybody looks into when any new system gets into production for solving any enterprise problems, that how many users have really adopted to this new way of looking at things or solving the problems. So, for widespread adoption, do you see any other key challenges that we need to solve as per the current dynamic capabilities of the agentic AI?
Yeah, it's a great question, right? So let's focus on the enterprise, right? Because like agents, I mean, enterprise is not the only domain. There are other domains too. But let's focus on the enterprise, right? Since in the context of our conversation, right? So I think in the context of the enterprise, really, um, I think the two most critical challenges here are reliability and determinism, right? Because that'll decide whether your systems are usable, right? And so if you think about reliability and determinism, right? Um, there are all kinds. There are a few different. Again, there are a few different trade-offs, a few different ways that you can go, right? And so, okay. So one way of so let's think about how we could improve reliability and determinism in the enterprise, right? So one way of thinking about it is, can we separate design time exploration versus runtime exploitation? Right. So maybe as you said, hey, they have dynamic capabilities, right? Well, how do we ensure reliability when you have dynamic capabilities? And maybe one way of doing that is that you explore during design time, like you figure out, oh, look, what are all the various things that I can, how are the various ways in which I can accomplish a task using this agentic system, and then you settle upon, a good flow, and then maybe at runtime things are a lot more deterministic, right? So at design time, you give the agentic system a lot of autonomy, and then at runtime, you hard code a lot of aspects, right? And that maybe that's one way of improving reliability, improving determinism. Maybe, of course, there's a trade-off there, right? You're increasing the amount of work you have to do. Um, a second thing is when your system makes an error, like sooner or later it will, presumably, right? How does it recover from that, right? Uh, and so, there's a couple of different ways of doing that. One way of doing that is your system should have the most critical thing is your system should be able to understand that it made an error, right? That it's gone wrong. And then either it should be able to replan around that error. It should look at the error and say, okay, I've made an error. Now let me do things differently and get better. Or there's a human in the loop, and the system should be able to invoke the human, right? And that's how it becomes more reliable and more deterministic, right? And I think this really becomes especially important when you think about role-based access, right? So when we think about enterprise systems, uh, a wrong action might have very significant cost, right? And depending upon the context, right, certain operations are more critical than other operations. If you're writing into an important database, you could do bad things if you make errors. And so, the orchestrator or the platform should have a sense of, when do I need to invoke a human? When do I need approval from a human? And you could do that, for example, when you know that whatever you're about to do is going to have a significant impact on the code process. It's going to result in a potential compliance or regulatory issue, and so it's vital that a human is in the loop to approve. It could have a high financial impact, et cetera, et cetera. So for important things, you need a human in the loop, perhaps. And then finally, there is this challenge of can my system get better over time as it builds experience, right? And I think, again, to me, this is my personal take on this is that isn't just an absolutely critical problem that we are going to have to solve. Without a system that improves and reliability with experience, I don't see how we're going to build systems that get widespread adoption in the enterprise.
Right. So we talked about reliability, determinism, as well as the importance of the system knowing that it has made certain error and how does it correct it. But based on the trade-offs and the use cases, we may have certain human in the loops as per the risk involved or the quantification of the risk involved. Is there. So all these points that we mentioned about, but I also want to bring your attention to one more issue of the adoption is the user interfaces. Now, why I say it is important is because a lot of the interactions which are going to happen with these agentic AI systems, they are going to be conversational in nature, or it is going to be like descriptive in nature, where you are writing about certain tasks, or it is going to be a combination of both, or in certain cases you may not even have the interface, but there is an automation which is running in the back end. So how do you see this aspect of, do you see any, foresee any different kind of user interfaces or suitable user interfaces from an adoption point?
Yeah, that's actually a great point, right? So I think this idea of about how do we solve the UX for AI problem, right? What is the user experience? What are the user interfaces to these agentic systems? I think that's a wide open problem, right? I suppose what we have today are really these a lot of these experiences are kind of chat interfaces, right? But then especially in the enterprise, you can imagine that many of your processes are not synchronous, they're asynchronous, right? They're not real-time interactions with the system. How do you make it easier for users to both design for these systems, right? Because a critical aspect of this is, again, that's the conversation we had about RPA. You're building automations, right? You're building these automations. How do we make it easier for users to build these automations on the one side? And then on the other side, how do you make it easier for users, for the end users to interact, to consume insights generated by these systems? I think both of those are just very wide open problems. And I think there's going to be very exciting work in the next few years on both of these aspects, right? And as I said, right, so maybe the enterprise and the consumer interfaces, there's some difference between the two, because some of the character of the work that you are doing is different. In one case, it's maybe largely real time. In the other, it's
Right.
maybe largely asynchronous. And secondly, there is the question that in the enterprise case, well, you have to design these systems too. Like you have to design the workflows. How do I build for you user interfaces that make your design time operation easier and not just your runtime? And that's a really open and a really interesting question, I think. And I'm excited to see what comes out in the next few years.
Right.
Maybe the next few months.
Yes. So the conclusion is that UI UX for agentic AIs systems is something up for grabs, both from a consumer standpoint and an enterprise standpoint. That's a takeaway there. So coming to the last question that we had for you today. So you talked about that aspect of the agentic AI knowing what is exactly it is getting to do, and an output, and analyzing the output, and if there are certain corrective steps to be taken, there is a verification involved. So self verification seems to be a hot topic in recent agentic AI literature, especially when you have multi-agent systems collaborating together to solve a problem. So can you break down how these systems perform self-checks and ensure the accuracy of their outputs?
Yeah, that's a great. It's a really critical point, right? It's a really critical topic. So Ketan, as you said, right? So really, if you think about verification, it goes back. Remember, like about 15 minutes ago, we were talking about design patterns, right? And so really, verification goes all the way back to the design pattern of reflection. That when the system does something, it should be able to reflect upon it and understand if it did things correctly. And as you just mentioned, in the enterprise setting, that is absolutely critical, right? Your agent should not make mistakes, or rather, it should not make undetected mistakes. If it makes a mistake, but then detects that, yes, I have made a mistake, then that opens up the possibility that it can replan, or even that it can flag the task to a human, so a human can take over, right? Both of those possibilities exist. But critically, you have to understand, you have to be able to, as you said, you have to be able to detect that you've made a mistake, right? And so, this governs both determinism and reliability, etc., right? So let's maybe start, let's think about how do you do self-verification, right? And so the simplest idea is, hey, use a specialized LLM-based agent that looks at your solutions. You came up with a plan, you executed the plan. the system change. Yeah? Things happen in the system. Give all of this to an LLM based agent, and that LLM based agent looks at what you did and says whether what you did was correct or incorrect, right? So you give the verifier essentially the user query and your own solution, and the verifier tries to judge, is the solution correct or is it good, right? And no, by the way, and if you think about it this way, how do you build that LLM verifier? Well, you could prompt engineer it, right? You could give it some rubrics in the prompt and say, oh, this is what you should look for. Or you could even train it, right? You could do fine tuning, you could train that specialized system. An even simpler solution is, you know what? Just run, it's the notion of self-consistency. Let's just run my system n times, let it generate n solutions, and then check, what the consistency between those is. And this idea of self-consistency, right, is an idea from 2023. There was a Google research paper, right, that first proposed this. And it showed that, oh, look, you can improve chain of thought by using self-consistency. Okay, so that's the basic idea, right? Have a simple verifier that looks at stuff and says yay or nay, right? And then you go from there. Digging one step deeper, there are many interesting questions and ideas here, right? First, there's the question of self-refinement. And self-refinement, again, I think was an idea from 2023, right? There was a paper in 2023 that first proposed it. And the idea in self-refinement is that, okay, you're verifying your own solution, but then based on whether, so you say, is the solution correct or incorrect, but you also critique the solution. You say, oh, it's wrong because of this, this, and this. And then the system can use that feedback to autonomously improve its own solution.
That's a continuous learning, the last point exactly. You made regarding the adoption continuous learning.
Exactly correct. And so the system just keeps, actually even so continuous learning is across tasks, but even within a task, a task, you could generate a solution, the verifier could say correct or incorrect, and then if it says incorrect, but it provides you feedback, and then within that task, you just try to come up with an improved solution. Yeah. So that's the self-refinement loop, right? So that's an important notion. But interestingly, it's not clear that the self-refinement loop always works, or whether it's always, or even that it's always necessary, right? So for example, last year there was a paper from Princeton that showed empirical results where they found that simple ideas like self-consistency outperform self-refinement for some of the problems that they tested. And then there are a bunch of papers actually over the last year and a half, including there was a paper on a system called SCORE from DeepMind. And that paper showed that this notion of iterative self-improvement or refinement needs to be done really carefully, else it has convergence issues. Right, you can converge your LLMs converge to really bad places. And then fourthly, there's a bunch of papers. There's this paper called V-Star. There's a paper called LLM Judge that showed that, oh, maybe you can, okay, so you have a self-verifier, but maybe it's possible to self-improve the self-verifier itself. So, we talked about self-improving the system, but it might also be possible to self-improve the verifier. And there's, a bunch of really cute and interesting ideas around how you could self-improve the verifier itself. And then finally, when we talk about validation or verification, there's the dimension of multimodality. Does your system need multimodal verification? And multimodal verification, on the one hand, makes things somewhat harder in terms of being able to judge correctness or incorrectness. But then there's certain problems on which the multimodal signal is just, essential. So when you start building a self-verifier, these are some of the questions you need to ask yourself. Is self-consistency good enough for me? Do I need to think about building a self-refining system? And is that even, and by the way, you need to test it, right? Is that even going to work for my problem? Do I need multimodality for this system, et cetera, et cetera? So, I'd summarize the takeaways / best practices here as, the first takeaway is self-verification is
before you do that, I just had one more thing to ask you on this one.
Yes,
so let me take this example that, there is an agent that you have built and it calculates correlation coefficients that you have in statistics. So if you take example of the correlation coefficients, generally, the answer of the correlation coefficient, there is a constraint on that it would lie between -1 and 1. So taking this as an example, we were talking about self consistency and the self refinement system. So let's say that the LLM and the LLM as a judge, which you were speaking about, let's say that there is a calculation that is done by the system, agentic system, and the correlation coefficient it has calculated comes out to be greater than 1 in this case. So now I wanted to ask you, what would be the response in context to self consistency, self refinement, and LLM as a judge?
Yeah, that's actually a really good question. Let's think about that. So what you're saying is, look, you know that there is, a mathematical constraint that your correlation coefficient, the absolute value has to be less than 1. And you do a combination and the absolute value turns out to be larger than 1, right? So now what does the system do? So I would imagine.
I've asked that as an example to put the broader constraint in the use cases in picture.
Sure. Absolutely, absolutely. So first, self-verification would imply that, hopefully what your verifier would do is that it would look at the solution and it would identify that, look, you have a mathematical impossibility here. So clearly this solution is incorrect, right? So at the very base level, it should be at least be able to say this is wrong. Right? And just that fact that your self-verifier says it's wrong then allows you to do more things, right? So the simplest idea here would be a self-verifier says this is wrong, and then the system says, oh, this is wrong, I need to invoke a human, right? Or, oh, this is wrong, let me try and redo the calculation. Right, and I'll give it to the verifier. That's the base level, right? And that's self-verification. Now, on top of this, self-refinement might work like the self-verifier doesn't just say it's wrong, it gives you feedback. Hey, this is wrong, and I think you went wrong in that step. And that's why you're getting a correlation that's, absolute value larger than 1. And then, if it can do that, then the self-refinement loop is that the system says, oh, my verifier component said this is wrong, but it gave me some feedback on why I might have gone wrong. Let me try and redo this, taking that feedback into account. And hopefully that helps it get to the correct solution. Right? That's self-refinement. And then the third piece of this is self-consistency, right? As you said. And so in self-consistency, the system just says, hey, you know what? Let me generate this answer n times. Let me run this calculation 10 times, right? And it can do it, you can play so many games there, right? You could do it with a high temperature so that you're getting, more stochasticity. You could do it by invoking different LLMs. Hey, let me invoke this LLM, that LLM, the other LLM. But you generate the answer 10 times, and then you have some self-consistency check. For example, you might say, oh, I'm going to take the majority vote. Like if 7 of those answers agree and 3 don't, I'm going to say that the answers in the 7 are the correct ones. So I think it's a really good example, Kiran. So I think that kind of illustrates the difference between self-based self-verification, self-refinement that gives you feedback, and then self-consistency, which says, oh, let me just do this calculation n times, and let me just, try to attain consistency.
Right. I think this was great, the way you put the example into picture. So yes, now we can, go to summarization of the takeaways that you were saying.
Yeah. So let me summarize. Yeah. Thank you. So let me summarize some of my takeaways, right? So self-verification, I think, might be, I don't know, it might, some days it feels like that is the most central problem of agentic systems for, to make them practical especially in the real world enterprise, right? It's just really hard for me to see how an agentic system can be reliable without good self-verification, right? So that's one piece. And by the way, now when I say the word self-verification, I'm including all these approaches.
All these, yes, of course.
Yeah, yes. Self-consistency, self-refinement, what have you. The second takeaway is that there are many, many possible approaches to take here, as we've discussed. And really, you probably want to take the simplest approach that works for your use case. We've said this a couple of times, but the same thing holds true for verification. There's many possibilities. You probably want to use the simplest possibility that works. But then the third takeaway here, and I think maybe one of the most important ones, is that you need the self-verification component. You need to extensively benchmark and test it. Because in some senses, your system is highly reliant upon that component. So that needs to be really extensively benchmarked and tested. You need to know how well does my verifier by itself work? Because, hey, your verifier might be inaccurate too. So how often does it catch errors? How often does it miss them? How often does it falsely flag correct solutions as being erroneous. You need to characterize all of that. And then you need to be able, you should have benchmarked it to the extent that you should be able to tell, say, how much impact does the verifier have on my overall system performance? The whole point of the verifier is that if you put it in, the reliability of your system, the accuracy of your system gets a lift. You should be able to you should have like extensive benchmarking on that. So really, that's, I think, the key takeaway. Self-verification is really important. There are many approaches. You need to figure out what the simplest thing that works for you, but then you need to extensively benchmark it.
Right, right. So benchmarking along with self-verification are both important based on the use case, the constraints that you put on the system, and what kind of outputs you are looking for from the system.
Yeah, and as the self-verification component itself, just separate from the rest of your system, the self-verification component you need to benchmark by itself.
Benchmark by
so
itself.
Yes. Yes, you have a good understanding of what it's doing.
Yes, yes. So, thank you, Ashish, for spending such amazing time with us and speaking about the agentic AI. So we talked about the use cases. We went through the differences it has with RPA 2.0. Then what are the architectural patterns? We talked about the evaluations. We talked about benchmarkings. And we talked about the self verification as well. So thank you again for being on the podcast, Neural Networking with Konverge AI. And we wish you all the best for the emergence journey that you are currently undergoing. Yeah.
Thank you. Thank you very much, Ketan. Thank you for having me on.